Hi guys, in lecture 7 we'll discuss the use of unit circle in trigonometry. So first we take a unit circle. So unit circle means the radius is 1 unit. So we draw a circle with radius as 1 unit and we draw the x and y axis. The center is at origin. So circle with center at origin and radius is 1 unit. So that means this length in each case is 1 unit, and this is the first quadrant, second quadrant, third and fourth quadrant. So the coordinates of this point will be 1, 0. This one is 0, 1 since it is on y-axis. This is on negative x-axis, so it is -1, 0, and on negative y-axis it is 0, -1. So we take any point on this circle. We take the point A and join it with origin. So this is also one of the radii. We take this angle as theta and draw the perpendicular from point A. So let this perpendicular meet the positive x-axis at B. We take the coordinates of point A as xy. Now we draw the triangle once again here, otherwise it is slightly difficult to make it very clear there. So I'm mentioning it as theta. This is 1. This is origin A and point B. Since this point is x, y, that means this vertical distance is always represented by the y coordinate. So this is y part, and the horizontal distance is represented by this x coordinate. Now using the concept Sohcahtoa, we first take the reference angle theta. This is the reference angle. According to this one, this is the opposite side. So the opposite side is y, adjacent is x, and hypotenuse is 1 unit. So sine of theta, according to this one, it is opposite upon hypotenuse. So we write sine theta is equals to, opposite is y upon hypotenuse is 1. That means we get y as sine theta. Again, using this curve, so it is cosine of theta is equal to adjacent. This is adjacent upon hypotenuse. So cosine of theta is adjacent is x and hypotenuse is 1. That means x is cosine theta. So this gives us that any point which is taken as x, y here on the unit circle with center at origin is then represented as x is cos theta, so it is cos theta, and y is sine theta. Now how do we use this? If we take a circle once again, unit circle, and this radius is 1, and suppose we take this angle as 30 degree, and this is some point P. So this point P will be cosine of this angle of inclination. So it is cosine 30 degree and sine 30 degree. So this point will be cosine 30 degree and sine 30 degree. So we know the values of cosine 30 and sine 30 degree, as we have covered this in the previous lecture related to special triangles 30 degree, 60 degree and 90 degree. So cosine 30 degree value is root 3 over 2 and sine 30 degree value is 1/2. So this point will be root 3 over 2 and 1/2. So this will make us easy to remember, like if we are able to write for 30, 60, 90 and all 30, 45, 60, 90 everything. So we'll able to find the values of the trigonometric ratios related to the corresponding angles it is making with positive x-axis. So now we take a bigger circle in which I'll show all the quadrants and also the angles corresponding to 30, 45, 60, 90 and the higher also in the other three quadrants. Now I have taken a unit circle. You can see it is quite big one here. So the corresponding angles, like 30 degree it is written. So that means 30 degree is this angle. That means with the positive x-axis, this radius is making an angle of 30 degree. This is the positive x-axis, positive y-axis, negative x-axis and negative y-axis. So if we say 45 degree, that means this angle is 45 degree. So how do we remember the values corresponding to cos 30, cosine 30, sine 30, cosine 45, sine 45 and likewise? So I'll tell you the method for that. So we first put a brackets. I'll be writing the coordinates here. So I'm putting the brackets first. In the first quadrant, as you know, both the coordinates x and y are positive. In this one, it is both positive. Here it is x negative and y positive. Here both are negative. So how do we remember this? So first write it like this. 1, 2, 3. And same way here. 3, 2, 1 in reverse order. Likewise in this way if we want to go, after 1 again we repeat this here. On the x part we are writing x coordinate 1, 2, 3 and here again in the reverse order it is 3, 2, 1. You can see it is now on its own, it is now again 1, 2, 3 likewise. 1, 2, 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. This you have to first write and then in this part now we write 1, 2, 3. Earlier we had written 1, 2, 3, now it is 1, 2, 3 like this. So here also it is 3, 2, 1, 1, 2, 3 and 3, 2, 1. Then divide, then we take root of all these numbers. So square root of 1 is 1. So we don't put the square root sign here. But otherwise for other two numbers we'll be putting the square root. So square root 3 like this for all these numbers. No square root for this required. So same way here. And then put the comma and divide each number by 2. Since x and y both are positive, so we don't have to put any sign. But here x is negative, so we'll write the negative sign here. Here also in this x and y both are negative, so we'll put negative for both. Here x is, sorry, in this case this is positive and negative. So x is positive, y is negative, so we'll put the negative sign for y coordinate. Now after writing this, like I've said 1, 2, 3 and like this, so how do we use it? So if you want to find, like in this case, for this angle 120 degree, if we want to find cosine of 120, always the x part will represent the cosine value and the y part will represent the sine value. So for sine 120 degree, so we have to see this one. Sine 120 is the y part, so it will be root 3 over 2. If we have to find cosine of 135 degree, so we go corresponding to this, and cosine means it is the x part, so it is minus root 2 over 2. Suppose we have to find sine of 210 degree. So we go corresponding to 210 and sine is the y part. So it is minus 1/2. Suppose we have to find cosine of 240 degree. So cosine of 240 degree is the x part corresponding to it. So it is minus 1/2. Then likewise sine 315 degree. So sine 350 degree go corresponding to this, and sine is the y part of it, so it is minus root 2 over 2. Now you can find sine as well as cosine for all these corresponding angles, and suppose you have to find out the tangent. So it is tangent 210 degree. So we write tangent 210 is sine 210 over cos 210. So sine 210. So it is the y part of this corresponding to it. So it is minus 1/2. And the cosine part is minus root 3 over 2. So minus gets cancelled. This root 2 also gets cancelled. So the result is 1 over root 3. So suppose we have to find now tangent of 330 degree. So tangent 330 degree is sine 330 degree over cosine 330 degree. So it is sine 330 degree corresponding to this is minus 1/2 and cosine of 330 degree is root 3 over 2. So this 2 gets cancelled, so it is minus 1 over root 3. So you can see that whichever result is required for tangent or sine or cosine, we can find by using this unit circle and these corresponding values. In this case, it is written in terms of radians also, and we know how to convert any degree into radians. Suppose it is 30 degree, so we multiply. Like in the previous lecture, I have already covered. Suppose we have to express 60 degree into radians. So 60 degree into radians is 60 into pi over 180. So this gets cancelled, so it is pi over 3 radians. Similar way, if it is, let us say 240 degree. So 240 degree is converted as 240 into pi over 180. We multiply it with pi over 180. So this gets cancelled, so it is 4 times and 3 times. So it is 4 pi over 3. So this way we can find all the degrees into radians, and we can find the values of all trigonometric ratios corresponding to these values and also the higher ones.